The winter morning lay still over the Belgian countryside. Inside the Panther tank numbered 432, Unteroffizier Klaus Weber adjusted his commander's periscope, scanning the tree line 3,000 yards ahead. His crew had survived 3 months on the Eastern Front. They had learned to trust their machine. The Panther's sloped armor had deflected Soviet shells that would have gutted lesser tanks. Its long 75mm gun could reach out and kill at ranges where enemy fire fell harmlessly short. Weber felt the familiar confidence that came with commanding 45 tons of German engineering. Then his gunner's voice cracked through the intercom. Movement, grid reference northwest. Looks like American. Through his optics, Weber caught a glimpse. Low profile, angular turret. The distinctive shape of an American tank destroyer, probably another M10 with its inadequate 3-inch gun. His crew had faced them before. The Wehrmacht had taught them that American anti-tank weapons were inferior, designed by a nation that understood industry better than warfare. The Panther could engage and destroy such targets before they came within effective range. Weber gave the order to traverse. His gunner began tracking the target. The electric motors hummed as the turret swung toward the threat. But something was different about this one. The barrel was longer, thicker. Weber's combat instinct screamed warning, but his training and experience told him he had time. At 3,000 yards, nearly 2 miles, no American weapon could threaten his Panther. He was wrong. The American gunner had already squeezed his trigger. 8 seconds. That was all the time Weber's crew had left to live. Before we jump back in, tell us where you're tuning in from, and if this story touches you, make sure you're subscribed because tomorrow I've saved something extra special for you. This is the story of a technological revelation that transformed the mathematics of armored warfare in the final year of World War II. It's about the moment when German tank crews, who had dominated European battlefields with technical superiority, discovered that America had built a weapon they didn't know existed. And it's about the brutal physics of long-range tank gunnery, where 8 seconds of shell flight time became the difference between hunter and hunted, between survival and cremation inside a steel tomb. By December of 1944, the war in Europe had reached a critical phase. Allied forces had broken out of Normandy and were pushing toward Germany's borders. But German resistance remained fierce, anchored by the most formidable tanks ever built. The Panther had earned its reputation through blood. Its frontal glacis plate, 80mm thick and angled at 55 degrees, created an effective thickness of roughly 140mm. Mathematics and metallurgy combined to create armor that Allied anti-tank guns could rarely penetrate. The Panther's firepower matched its protection. The 75mm KUK 42L70 gun could destroy Allied tanks at ranges exceeding 2,000 yards. German crews had learned to engage from positions where return fire was either impossible or ineffective. This combination of range, armor, and firepower had created a psychological dominance that extended beyond mere technical specifications. The Tiger series tanks took this superiority even further. The Tiger I, with its 88mm gun and 100mm of frontal armor, had become a legend of invincibility. The newer Tiger II, or King Tiger, pushed the boundaries of tank design with over 7 inches of frontal armor and a gun that could penetrate any Allied tank from 3 miles away. For German tank crews, these machines represented not just military hardware, but proof of technical and tactical supremacy. American tankers had learned to fear these beasts. Reports from Normandy and the fighting in France told a consistent story. Sherman tanks, the backbone of American armored forces, were hopelessly outmatched. Their 75mm guns could barely scratch Panther armor at combat ranges. Crews watched their shells spark harmlessly off German armor, while 88mm rounds punched through their own thin protection like it wasn't there. The mathematics were cruel and absolute. A Sherman needed to close to within 500 yards to have a reasonable chance of penetrating a Panther's side armor. At that range, the Panther could destroy the Sherman with a single shot from any angle. Veteran tank commanders developed tactics built around this disparity, attempting to flank German armor or call in artillery and air support, rather than engaging directly. But these tactics required favorable terrain, good intelligence, and often cost lives in their execution. The American response had been to field tank destroyers, specialized vehicles designed to hunt and kill enemy armor. The M10, with its 3-inch gun, had shown initial promise against medium German tanks. But as Panthers and Tigers became more common, the M10's limitations became painfully apparent. Its shells lacked the velocity and mass needed to penetrate heavy armor at safe ranges. The M18 Hellcat offered speed and agility with its 76mm gun, but it too struggled against German heavy armor. American crews found themselves in an arms race they appeared to be losing. German engineers kept building thicker armor and more powerful guns, while American weapons seemed to fall further behind. The doctrinal answer, overwhelming German armor through numerical superiority and combined arms tactics, worked in theory, but cost American lives in practice. By autumn of 1944, American forces desperately needed a weapon that could engage German heavy tanks on equal terms. That weapon had been in development since early 1943, but bureaucratic delays and production challenges had kept it from the front lines. When it finally arrived in September of 1944, German intelligence had no idea it existed. The M36 tank destroyer looked similar enough to the M10 that German crews initially mistook them for the same vehicle. Both shared the open-topped turret design that characterized American tank destroyers. Both used variants of the Sherman tank's chassis and running gear, but where the M10 mounted a 3-inch gun, the M36 carried something entirely different. The 90mm M3 gun had begun its life as an anti-aircraft weapon designed to reach up and tear apart high-flying bombers. American ordnance engineers had recognized that any weapon capable of destroying aircraft at 20,000 feet would have devastating potential against ground targets. The challenge had been adapting this massive gun for tank destroyer use. The 90mm cannon was far heavier than the 3-inch gun it would replace. It generated tremendous recoil forces that the existing M10 turret simply couldn't handle. Engineers had designed an entirely new turret, larger and more robust, with an electric traverse system that could swing the heavy gun quickly onto target. The technical specifications revealed the weapon's potential. The standard M82 armor-piercing capped round left the barrel at 2,650 feet per second. This wasn't dramatically faster than the German 88mm gun on the Tiger I, but the American round was significantly heavier and carried more kinetic energy. At 1,000 yards, it could penetrate nearly 5 inches of vertical armor plate. But it was the special HVAP round high-velocity armor piercing that truly made the M36 deadly. These rare tungsten cord projectiles screamed from the barrel at 3,350 feet per second. At combat ranges, they could punch through nearly 8 inches of steel. No tank in the German arsenal, not even the King Tiger, was safe from a well-placed 90mm HVAP round. The physics of long-range tank gunnery would determine how this weapon performed in combat. When an M36 gunner fired at a target 3,000 yards away, his shell didn't travel in a straight line. Gravity began pulling the projectile downward from the moment it left the barrel. Air resistance steadily sapped its velocity. The shell followed a curved trajectory, rising initially, then arcing downward toward its target. At 3,000 yards, with the standard M82 round, the flight time was approximately 8 seconds. 8 seconds where the shell traveled through atmosphere, fighting drag and gravity. 8 seconds where wind could push it off course. 8 seconds where the target might move, might turn, might present a different angle. For the American gunner, those 8 seconds required precise calculation. Range estimation had to be exact. The M36 used the M76F telescopic sight, graduated for different ranges and ammunition types. An experienced gunner learned to read terrain, to estimate distance by sight, to compensate for wind and the movement of his own vehicle. The best crews could hit targets consistently at ranges exceeding 2,000 yards. For the German tank crew on the receiving end, those same 8 seconds represented something entirely different. If they spotted the muzzle flash, if they recognized the threat, they had 8 seconds to react, 8 seconds to traverse their own gun toward the threat, 8 seconds to identify the target and lay their sights, 8 seconds to fire their own round and hope it reached the American tank destroyer first. But the terrible reality was that most German crews never saw the muzzle flash. The M36's low profile and careful positioning meant the first indication of its presence was often the impact of its 90mm shell. Tank destroyer doctrine emphasized ambush tactics. American crews were trained to find concealment, to wait for German armor to enter their engagement zone, to fire first and accurately. The sound would arrive before the shell. Physics dictated that the supersonic projectile outpaced its own noise. A German commander might hear the distant crack of the 90mm gun and have perhaps 6 seconds to realize what it meant. The shell itself made no sound as it cut through the air, invisible death traveling at over 2,000 feet per second. When the tungsten penetrator struck Panther armor, physics and metallurgy collided with explosive results. The kinetic energy mass times velocity squared concentrated into a projectile smaller than a man's fist. This energy had to go somewhere. If the armor held, the shell might deflect, skating across the surface in a shower of sparks. More often, at ranges under 3,000 yards, the tungsten core punched through. The penetration process happened in milliseconds. The shell created a pressure wave in the metal that traveled faster than the projectile itself. The armor plate, stressed beyond its molecular limits, failed catastrophically. Metal fragments erupted into the tank's interior at supersonic velocity. These spalling fragments killed crews more often than the shell itself, turning the tank's own armor into deadly shrapnel. If the shell carried its explosive filler through the armor, detonation followed instantly. Inside a tank, there was nowhere for the blast pressure to escape. The overpressure alone could be lethal. More often, the penetration ignited ammunition or fuel. German tanks carried their main gun ammunition in sponsons along the sides, convenient for the loader but tragically vulnerable to penetration. A hit that reached the ammunition meant instant catastrophic explosion. Panther crews called it brewing up, the moment when their tank transformed from a fighting vehicle into a funeral pyre. The ammunition explosion would blow the turret off the hull, sending it spinning through the air. Smoke and flame erupted from every opening. Crew members lucky enough to survive the initial penetration had seconds to escape before burning alive. German tank crews had standing orders to wear their leather jackets with the collars up even in summer, hoping the leather might protect against burns during emergency egress. The introduction of the M36 into combat came at a pivotal moment. Hitler had committed Germany's remaining armoured reserves to one final offensive in the West, a desperate gamble to split the Allied armies and recapture the port of Antwerp. The attack would come through the Ardennes forest, the same region where German Panthers had achieved their stunning breakthrough in 1940. This time would be different. German industry had strained to provide the tanks needed for the offensive. Over 2,000 armoured vehicles had been assembled, including the newest variants of the Tiger and Panther. German crews were less experienced than in previous years. The Eastern Front had consumed the veterans, but they still trusted in their tanks' technical superiority. They had no intelligence about the M36. German reconnaissance had noted new American tank destroyers but assumed they were variants of the M10 or M18. The distinctive longer barrel of the 90mm gun hadn't been properly reported to frontline units. When the offensive began on December 16, 1944, German tank crews believed they still held the advantage in any armor versus armor engagement. The American forces in the Ardennes were initially surprised and overwhelmed by the German attack, but scattered among the defensive positions were elements of tank destroyer battalions equipped with the new M36. These units would provide the first combat test of whether the 90mm gun could match German armor. The answer would come quickly, measured in 8-second intervals of shell flight time, in the flash of tungsten on steel, in the sudden transformation of German confidence into terror. What happened next would fundamentally alter the balance of armoured warfare in Europe. For the first time since 1942, German tank crews would face weapons that could destroy them at ranges they considered safe. The 8 seconds between firing and impact would become 8 seconds of helplessness, watching death approach at supersonic velocity with no time to respond. The hunters were about to discover what it felt like to be hunted. The first engagement between German Panther tanks and the M36 tank destroyer occurred not with thunder but with silence breaking. On the morning of December 17, 1944, near the Belgian town of St. Vith, Sergeant William Morrison of the 814th Tank Destroyer Battalion sat in his M36, watching the forest road through his optics. Morrison had been a tank destroyer crewman since North Africa. He'd fought in Sicily, survived Italy, and landed in France 3 weeks after D-Day. He'd seen what German tanks could do. He'd watched M10s burn after hopeless engagements with Panthers. He'd learned the hard mathematics of penetration and deflection, the cruel geometry that made some battles unwinnable before they began. But now he commanded an M36, and the mathematics had changed. Through the morning mist, shapes emerged. German armour, moving with the methodical confidence of units that expected no effective resistance. Morrison counted 3 Panthers in column, advancing down the narrow road toward American positions. Standard German tactics use the heavy tanks to punch through, then exploit with infantry and lighter vehicles following behind. Morrison's gunner, Corporal James Hayes, had already ranged the lead Panther, 2,800 yards, well within the theoretical range of the 90mm gun, but farther than most crews had trained to engage. Hayes had fired exactly 12 rounds from the M36's main gun since receiving the vehicle, 3 weeks earlier. Ammunition for training had been limited, the weapon too new, too valuable to waste shells on practice. High-velocity armour-piercing, Morrison ordered. His loader, Private Anthony Costa, pulled one of the precious HVAP rounds from the turret storage. These tungsten-cored shells were rationed strictly. Each M36 carried perhaps a dozen at most. The rest of their ammunition was standard M82, adequate for most targets but less certain against heavy frontal armour at extreme range. Costa loaded the round with practiced efficiency despite never having done so in combat. The breech clanged shut. Hayes made minute adjustments to his sight picture, compensating for the range, for the slight crosswind that bent the trees. His training told him to aim for the Panther's turret, where the armour was thinner and more vulnerable than the heavily sloped glacis plate. The M36 rocked backward as Hayes fired. The 90mm gun produced a muzzle blast that momentarily blinded everyone nearby, a wall of pressure and flame that kicked up dust and debris. Morrison counted silently. 1001, 1002. The shell was already halfway to its target, invisible, supersonic, carrying kinetic energy measured in millions of foot-pounds. 1003, 1004. Inside the Panther, the German crew had perhaps heard the report of the gun. Perhaps they were beginning to react, to traverse their turret, to search for the threat. 1005, 1006. The shell was descending now, gravity and air resistance pulling it down from the peak of its trajectory. 1007, 1008. The Panther's turret erupted in a gout of flame and metal. Even at nearly 3 miles distance, Morrison saw the catastrophic failure. The tungsten penetrator had punched through 100 millimeters of cast armor as if it were tin. Inside, the explosive filler detonated among the crew and ammunition. The turret lifted slightly. Then, flames poured from every opening. No one escaped. The second Panther in column stopped immediately. Its commander had just watched the lead vehicle destroyed by a weapon he didn't know existed, from a range he'd believed was safe. Morrison could imagine the frantic radio calls, the confusion, the desperate attempts to locate the threat. But the second Panther made a fatal mistake. It remained stationary while searching for its attacker. Hayes had already loaded a second HVAP round. The range was marginally shorter now, perhaps 2,600 yards. He adjusted his aim and fired again. 8 seconds later, the second Panther suffered the same fate. The third Panther, its commander apparently deciding that any direction was better than staying in this killing zone, began backing up frantically, attempting to reverse at speed down the narrow road. Standard M82 ammunition, this time they couldn't afford to waste another HVAP round. Hayes fired. The shell struck the Panther's side armour as it manoeuvred, penetrating where the thinner 40mm plates offered little protection. The tank shuddered, smoke billowing from the engine compartment. The crew bailed out, abandoning their disabled vehicle and running for the forest. 3 Panthers destroyed or disabled in less than 2 minutes. At ranges that German doctrine considered safe, by a single American tank destroyer that the enemy didn't know existed. This engagement was not unique. Across the Ardennes, as German forces pushed forward in their desperate offensive, they encountered the M36 again and again. Each encounter followed a similar pattern: confusion, surprise, and the terrible realization that American anti-tank capability had fundamentally changed. Lieutenant Alfred Rose of the 814th Tank Destroyer Battalion achieved what would become the longest confirmed tank kill of the European War. His target was a Panther prowling the ridgeline near the village of Eschweiler. Rose's gunner carefully ranged the target 4,600 yards, nearly 2 6/10 miles, the maximum range of their M76F telescopic sight. At that distance, the shell flight time extended beyond 10 seconds. Wind drift became significant. Even minor errors in range estimation would cause complete misses. Rose ordered high-velocity armor-piercing ammunition, the only round that could maintain enough velocity to penetrate at such extreme range. His gunner made the necessary calculations, estimating holdover and wind deflection by experience and instinct rather than precise measurement. The shot seemed impossible. Hitting a target the size of a Panther at over 2 miles required perfect conditions and exceptional skill. When the gun fired, Rose couldn't even see the impact clearly through his optics at that range, but observers reported flames erupting from the distant Panther. The crew had achieved what many experts would have deemed impossible: a first-round hit at maximum range against a moving target. Corporal Anthony Pinto of the 740th Tank Destroyer Battalion matched this achievement, destroying a Panther at 4,200 yards during the fighting around Bastogne. These extreme-range kills demonstrated not just the M36's technical capability, but the skill of American tank destroyer crews. They had trained for precisely this scenario, engaging German armor at ranges where return fire was difficult or impossible. But the M36's introduction to combat revealed challenges alongside its successes. The open-topped turret design, chosen to save weight and improve visibility, left crews vulnerable to indirect fire. German artillery had learned to target American tank destroyers with air-burst shells that scattered deadly fragments into the open fighting compartment. During the defense of Braunschweig in early February of 1945, Captain James Ducoursois commanded Company B of the 610th Tank Destroyer Battalion. His M36S supported an infantry assault against German positions, providing direct fire support against bunkers and strongpoints. For 60 consecutive hours, his tank destroyers fought under constant artillery fire. Shrapnel rained down into the turrets, destroying radios, periscopes, and gun sights. Several crew members were wounded by fragments that would have been stopped by an enclosed turret. Private First Class Canterbury had his radio operator's hatch blown completely off by a near miss from a German shell. He climbed out of the turret under fire, retrieved the heavy hatch, and reinstalled it while artillery continued to fall around his position. Such actions were not exceptional, but routine tank destroyer crews accepted the vulnerability as the price for mobility and firepower. The psychological impact of the M36 on German tank crews proved as significant as its technical performance. Wehrmacht training had emphasized the technical superiority of German armor. Panther and Tiger crews had been taught that they represented the pinnacle of armored warfare, that their machines were the best in the world. This belief wasn't mere propaganda. It had been confirmed by years of combat experience where German tanks consistently outperformed Allied armor. The sudden appearance of a weapon that could destroy Panthers at 3,000 yards shattered this confidence. German tank commanders, who had grown accustomed to engaging from positions of invulnerability, discovered they were vulnerable at ranges they'd considered completely safe. After-action reports from German units began noting new American anti-tank weapons of exceptional power and warning crews to avoid exposing themselves at any range. The mathematics of tank combat had shifted fundamentally. Previously, a Panther could engage American armor from 2,000 yards with reasonable certainty of success and minimal risk. The Sherman's 75mm gun was ineffective at that range, and even the 76mm guns on newer Shermans struggled to penetrate Panther armor beyond 1,000 yards. This meant German tanks could control large areas of terrain simply by positioning themselves at standoff ranges. The M36 eliminated this advantage. Now, German crews had to assume that any American position might contain a tank destroyer capable of killing them at any range. This forced German armor to operate more cautiously, to avoid exposure, to limit their movement during daylight hours. The psychological effect compounded the tactical impact. Even when M36s weren't present, German crews operated as if they might be. If you find this story engaging, please take a moment to subscribe and enable notifications. It helps us continue producing in-depth content like this. Testing conducted by the 703rd Tank Destroyer Battalion in December of 1944 revealed both the M36's capabilities and its limitations. Against captured German vehicles, crews conducted systematic penetration tests at various ranges and angles. The results were encouraging but sobering. Against Panther tanks, the 90mm gun could reliably penetrate the turret armor at any combat range. The 100mm curved mantlet, while thick, couldn't resist HVAP rounds even at extreme distances. Side armor was vulnerable to standard M82 ammunition at ranges exceeding 1,500 yards. But the frontal glacis plate, 80mm thick at 55 degrees, proved more challenging than expected. At certain angles and ranges, even the powerful 90mm gun could be defeated by the Panther's geometry. Shots striking the glacis at oblique angles might deflect harmlessly. This required American crews to be selective about engagement angles and ammunition choice. The doctrine evolved quickly: aim for the turret when possible, use HVAP rounds when targeting heavy frontal armor, and accept that some positions made penetration unlikely regardless of weapon. The King Tiger presented an even greater challenge. Testing revealed that the frontal armor, over 7 inches thick in places, could defeat standard M82 ammunition at nearly any range. Only HVAP rounds offered reliable penetration, and even then, frontal engagements were risky. The 703rd's report concluded that M36 crews should avoid frontal engagement with King Tigers unless using HVAP ammunition, and should instead maneuver for side or rear shots whenever possible. This tactical limitation didn't prevent M36 crews from engaging King Tigers successfully. Near Freihaldenhoven in late December, an M36 from the 702nd Tank Destroyer Battalion encountered a King Tiger at approximately 1,000 yards. Rather than attempt a frontal engagement, the American crew maneuvered to expose the German tank's flank. A single 90mm round penetrated the King Tiger's turret side armor, detonating the ammunition and destroying the vehicle. The engagement highlighted the difference between technical specifications and tactical reality. On paper, the King Tiger was nearly invincible. In practice, its slow turret traverse and limited mobility made it vulnerable to aggressive crews who understood how to exploit those weaknesses. The M36 provided the firepower. Skilled crews provided the tactics to use that firepower effectively. German responses to the M36 evolved throughout the Ardennes campaign. Initial encounters produced confusion and shock. As awareness spread, German commanders began instructing their tank crews specifically to identify and prioritize M36 targets. Intelligence reports attempted to determine how many of these new tank destroyers the Americans possessed and how widely they were deployed. The answer troubled German planning staff. By late December, 7 tank destroyer battalions had received M36s, with more converting from older vehicles every week. Each battalion fielded 36 tank destroyers. The numbers suggested that American long-range anti-tank capability was improving precisely. When German armor resources were dwindling and irreplaceable, German tactical responses focused on avoiding long-range engagements where the M36 held advantage. Tank units received orders to close range quickly, to use terrain and darkness to approach American positions without exposing themselves at standoff distances. Infantry received increased numbers of Panzerfausts and Panzerschrecks, shoulder-fired anti-tank weapons effective against the M36's thin armor at close range. These tactics achieved some success. Several M36s were destroyed by German infantry who infiltrated close to American positions under cover of darkness or heavy terrain. The open-topped turret made tank destroyers particularly vulnerable to grenades dropped from above in urban fighting. But these tactical adjustments couldn't overcome the fundamental shift in armored warfare's mathematics. The Battle of the Bulge reached its crisis point in late December. German forces had achieved initial success through surprise and overwhelming local superiority, but they failed to capture critical objectives on schedule, and American resistance stiffened as reinforcements arrived. Tank destroyer battalions played a crucial role in this defense. The 610th, 740th, and 814th Tank Destroyer Battalions, all equipped with M36s, suffered casualties exceeding 60% of their original strength during the heaviest fighting. These losses reflected the intensity of combat and the vulnerability of open-topped vehicles to artillery fire. But despite these casualties, the battalions claimed over 300 confirmed tank kills during the campaign. Patton's Third Army, driving north to relieve besieged Bastogne, reported that tank destroyer battalions accounted for over one-third of all German armoured vehicles destroyed during their offensive. The M36's ability to engage German armour at extended ranges allowed American forces to establish defensive lines that German tanks couldn't easily penetrate. Villages that should have fallen in hours held for days, anchored by tank destroyer positions that dominated the approaches. The experience transformed American tactical doctrine for armor employment. Tank destroyer units, previously viewed with some skepticism by conventional armor commanders, gained newfound respect. The aggressive hit-and-run tactics that had seemed suicidal against German heavy tanks became viable when backed by the 90mm gun's killing power. German commanders recognized they faced a fundamental problem. Their armored forces, designed to achieve breakthrough and exploitation, were being systematically destroyed by American defensive weapons they couldn't effectively counter. Every engagement with M36s cost German tanks they couldn't replace. Every day of continued offensive operations depleted armoured reserves needed for defensive operations back inside Germany. By early January of 1945, the German offensive had failed. Lack of fuel, mounting casualties, and the inability to achieve breakthrough against stiffening American resistance forced a general withdrawal. German armour that had advanced so confidently in mid-December retreated in disarray, harassed by American tank destroyers, whose 90mm guns reached out across the snowy landscape to kill Panthers and Tigers at ranges German crews had once considered safe. The 8 seconds of shell flight time at 3,000 yards had become 8 seconds of helplessness for German tank crews. 8 seconds where they couldn't maneuver, couldn't return fire effectively, couldn't do anything but hope the American gunner had miscalculated. 8 seconds that often ended in penetration, fire, and death. For American crews, those same 8 seconds represented confidence restored. They finally possessed a weapon that could fight German heavy tanks on equal terms. The psychological burden of technical inferiority had lifted. Tank destroyer crews sought engagement with German armour rather than avoiding it. The hunters and the hunted had traded places. When the smoke cleared from the Ardennes forests in late January of 1945, the battlefield told its story through twisted metal and burned-out hulks. Wrecked German tanks littered the roads and fields, testimony to the most desperate armoured offensive Germany would ever launch in the West. Among the casualties, Panthers and Tigers bore the distinctive puncture wounds of 90mm penetrators. American intelligence teams moved through the battlefield, documenting destroyed vehicles and interviewing captured German tank crews. The assessments confirmed what combat had already demonstrated: the M36 had fundamentally altered the balance of armoured warfare. One German Panzer officer, captured near Bastogne, provided a stark summary when interrogators asked about the new American tank destroyer. "We didn't know you had such a weapon. If we had known, we would have planned differently." The statement revealed more than tactical surprise. It exposed how completely German intelligence had failed to track American weapons development. The M36 had been in production since mid-1944. Hundreds had been manufactured and shipped to Europe. Yet German reconnaissance had missed or misidentified them, assuming they were simply upgraded versions of existing tank destroyers. This intelligence failure cost German armour dearly during the Bulge. But the deeper significance lay in what the failure represented. Germany's ability to gather intelligence, to track enemy capabilities, to adapt doctrine based on emerging threats, all these had deteriorated by late 1944. The Wehrmacht, that had dominated Europe through superior intelligence and tactical flexibility, was now fighting blind, reacting to surprises rather than anticipating them. American tank destroyer doctrine had also evolved through combat experience. The pre-war theory emphasized speed, and mobility tank destroyers would race to threatened sectors, establish ambush positions, destroy enemy armor, then redeploy before counterattack. In practice, this doctrine had proven difficult to execute, especially when facing German tanks whose range and armor made aggressive maneuver suicidal. The M36 changed these calculations. Its firepower allowed tank destroyer units to establish positions at ranges where German return fire was less effective. Crews could engage from prepared positions that provided cover and concealment while still maintaining sight lines to potential targets thousands of yards away. The doctrine of aggressive maneuver gave way to deliberate positioning and patient ambush. As Allied forces pushed into Germany proper in early 1945, the M36 continued proving its worth. The fighting for the Rhine crossings in March showcased the tank destroyer's versatility. At Remagen, where American forces captured an intact bridge across the Rhine, M36S provided crucial fire support against German counterattacks, attempting to destroy the bridge or push back the American bridgehead. German armor, desperately committed to eliminate this penetration of their last major defensive line, discovered that the open terrain around the Rhine offered little cover from long-range anti-tank fire. M36S, positioned on the western bank, could engage targets on the eastern side at ranges exceeding 3,000 yards. Panthers attempting to approach the bridge found themselves under accurate fire long before they could bring their own guns to bear effectively. The psychological impact on German tank crews had become cumulative. Months of fighting against increasingly capable American anti-tank weapons had eroded the confidence that German armor had once possessed. Veterans who had survived the Eastern Front and earlier campaigns in the West now faced an enemy whose weapons could match their own. The technical superiority that had sustained German morale was evaporating. Ammunition logistics revealed another critical factor. The HVAP rounds that made the M36 truly deadly against heavy armor remained scarce throughout the war. American industry never produced these tungsten cord penetrators in quantities sufficient to equip all tank destroyers adequately. Crews continued rationing HVAP ammunition, reserving it for encounters with Panthers, Tigers, and other heavily armored targets. This scarcity forced tactical decisions that affected engagements. When American crews identified enemy armor at long range, they had to decide quickly whether to use precious HVAP rounds or standard M82 ammunition. Against known Panther or Tiger tanks, the choice was clear. Against unidentified targets or medium German tanks, crews often fired standard ammunition first, accepting reduced penetration capability to preserve their limited HVAP stocks. The production numbers told their own story about American industrial capability. From September 1944 through May 1945, American factories produced over 2,000 M36 tank destroyers in various configurations. The original M36 used the M10A1 chassis. The M36B1 variant mounted the turret on an M4A3 Sherman chassis. The M36B2 used the earlier M10 chassis with diesel engines. All three variants carried the same main armament and provided similar combat capability. This production feat, accomplished while simultaneously manufacturing thousands of Sherman tanks, artillery pieces, aircraft, and other weapons, demonstrated the industrial advantage that ultimately doomed Germany. By early 1945, German tank production had collapsed under bombing, resource shortages, and transportation disruption. Each Tiger or Panther destroyed in combat became irreplaceable. America could replace its losses within weeks. The final battles in Germany showcased this disparity. German armored units, once the terror of European battlefields, were reduced to scattered, company-sized formations operating with minimal supplies and inadequate fuel. American armored and tank destroyer units encountered German armor increasingly in defensive positions, hull down behind rubble or concealed in forests, conserving fuel and ammunition for last-ditch defensive stands. These engagements favored the M36's strengths, long-range precision fire against stationary or slow-moving targets. German tanks attempting to defend fixed positions couldn't employ their mobility or tactical skill. They became targets for American gunners who could take time to aim carefully, to use terrain for protection, to engage methodically rather than in desperate close-range encounters. By May of 1945, when Germany surrendered, the M36 had established itself as the most effective American tank destroyer of the war. Combat records showed kill-to-loss ratios that vindicated the weapon's design and the crew's training. More significantly, the M36 had achieved its strategic purpose. It neutralized German armor's tactical dominance and restored American confidence in their ability to defeat heavy tanks. But the M36's story didn't end with Germany's surrender. The tank destroyer remained in American service through the occupation period, and when war erupted in Korea in 1950, M36S returned to combat. The North Korean People's Army fielded Soviet-supplied T-34-85 tanks that American infantry weapons couldn't easily defeat. Tank destroyers shipped from occupation duty in Japan and European storage depots provided crucial anti-armor capability. In the hills and valleys of Korea, the M36 demonstrated that its 90mm gun remained relevant against post-war armor. T-34 tanks, formidable opponents to the light American armor initially available in Korea, proved vulnerable to 90mm fire at ranges that kept M36 crews relatively safe from the Soviet tank's 85mm gun. The engagements echoed those in Europe, American crews using range and firepower to offset their vehicles' light armor. The M36 saw service far beyond American forces. Under military aid programs, the United States supplied tank destroyers to allied nations worldwide. France, Yugoslavia, Pakistan, Iran, Taiwan, and others received M36S during the 1950s and 60s. Many nations modified the vehicles, replacing the original engines with more reliable diesel power plants and updating fire control systems. Yugoslavia's experience with the M36 proved particularly notable. The Yugoslav People's Army received nearly 400 M36 tank destroyers and kept them in service through the 1990s. During the Yugoslav wars of the early 1990s, these World War II-era tank destroyers saw combat once again, their 90mm guns still capable of destroying modern armor under the right conditions. The longevity demonstrated how fundamentally sound the M36's design had been. Pakistan deployed M36S during the Indo-Pakistani Wars of 1965 and 1971. The Second Kashmir War saw M36S of the Pakistani 11th Cavalry engage Indian Centurion tanks, a matchup that pitted World War II American design against post-war British armor. Despite mechanical reliability issues, Pakistani M36 crews achieved several confirmed kills against the more modern Centurions, proving that superior gunnery and tactics could overcome technical disadvantages. The technical legacy of the M36 extended beyond the vehicle itself. The 90mm gun proved so successful that it became the basis for post-war American tank armament. The M26 Pershing heavy tank and its successor, the M46 Patton, both mounted variants of the 90mm gun. Development work on improved ammunition and fire control systems for these guns, built directly on combat experience, with the M36. The open-topped turret design, controversial throughout the M36's service life, influenced post-war thinking about armored vehicle design. While most nations moved toward fully enclosed fighting compartments for main battle tanks, the lessons about visibility and situational awareness that American tank destroyer crews learned remained relevant. Modern armored vehicles incorporate extensive vision systems precisely because combat demonstrated how crucial it is for crews to see their surroundings. The tactical doctrine that evolved around the M36 long-range precision engagement from prepared positions anticipated modern anti-tank warfare. Current military doctrine emphasizes exactly the same principles. detect the enemy first, engage at maximum effective range, use terrain for protection, and exploit superior fire control and ammunition to defeat heavier armor. The M36 crews who perfected these tactics in 1944 and 45 established patterns that remain valid today. The human cost of operating M36S deserves recognition alongside the technical achievements. Tank destroyer crews suffered casualty rates comparable to or exceeding those of tank units. The open turret that provided visibility also exposed crews to artillery, small arms fire, and the fragments from near-miss explosions. Cold, wet, exhausted, these crews fought from vehicles that offered minimal protection and demanded constant maintenance under combat conditions. Private First Class Canterbury, who replaced his blown-off hatch under fire near Brandscheid, received no medal for his action. It was considered simply doing his job. Thousands of similar acts of courage and dedication went unrecorded and unrewarded. Tank destroyer crews accepted extraordinary risks because they believed in their mission and trusted their weapon. The M36 validated that trust by giving them the firepower to survive and win engagements that older tank destroyers couldn't. The statistical record of the M36's combat service provides cold numbers that represent human drama. Tank destroyer battalions in Europe claimed over 1,000 confirmed tank kills between September 1944 and May 1945. Not all these kills were by M36S, M10S and M18S continued serving alongside the newer vehicle, but M36-equipped battalions consistently reported higher kill ratios and greater success against heavy German armor. These statistics represented individual moments of terror and triumph. Each confirmed kill meant a German crew killed or captured, a multi-ton machine reduced to scrap metal. Each American loss meant crews killed or wounded, families receiving telegrams, units rebuilding and replacing casualties. The mathematics of armor penetration and shell flight time translated into human consequences measured in lives lost and battles won. The 8 seconds of flight time at 3,000 yards became symbolic of the M36's impact. Those 8 seconds represented the span between the American gunner's decision to fire and the moment of impact. For German crews, those 8 seconds marked the difference between confidence and catastrophe. The ability to deliver accurate, lethal fire across that distance transformed the tactical and psychological balance of armored warfare. German tank crews who had spent years believing in their technical superiority learned in those 8 seconds that American industry and ingenuity had caught up. The Panthers and Tigers that had dominated European battlefields were vulnerable, mortal, defeatable. This realization spread through German armored units, eroding morale and forcing tactical changes that reduced armor effectiveness. American crews learned different lessons in those same 8 seconds. They discovered that training, skill, and adequate equipment could overcome seemingly impossible odds. The tank destroyer doctrine that had seemed questionable when facing superior German armor proved viable when backed by the 90mm gun. Confidence replaced fear, aggressiveness replaced caution. The M36's legacy ultimately rests on this transformation. It arrived at the moment when American forces desperately needed a weapon that could engage German heavy tanks successfully. It provided not just the technical capability, but the psychological boost that came from possessing adequate firepower. Tank destroyer crews who had felt outgunned and vulnerable suddenly became the hunters rather than the hunted. In the winter forests of Belgium, in the rubble of German cities, across the bridges spanning the Rhine, the M36 proved that American military innovation could match the best weapons any nation could produce. The open-topped turret, the powerful 90mm gun, the chassis borrowed from the reliable Sherman, these practical design choices created a weapon that arrived in time to make a decisive difference. Klaus Weber, the German Panther commander from our opening, never understood what killed him. His crew died in the explosion before they could identify the threat or return fire. The 8 seconds between the M36's muzzle flash and the penetrator's impact gave them no time to react. They joined thousands of other German tank crews who discovered too late that American anti-tank capability had evolved beyond their intelligence estimates. The American crew that fired that shot, we don't know their names with certainty, as records of specific low-level engagements often went unrecorded survived the war. They continued engaging German armor through the winter and spring campaigns, each encounter lasting those same 8 seconds of flight time. Some survived, some didn't. But collectively, they and thousands of other M36 crews accomplished their mission. They stopped the German armoured offensive in the Ardennes. They supported the Rhine crossings. They provided the anti-tank firepower that allowed American infantry and armour to advance into Germany with confidence that German heavy tanks could be defeated. The technical specifications, the penetration tables, the ballistic calculations, all these mattered less than the simple fact that American crews finally possessed a weapon adequate to the task. Up next, you've got 2 more standout stories right on your screen. If this one hits the mark, you won't want to pass these up. Just click and check them out. And don't forget to like, subscribe, and turn on the notification bell so you don't miss any upload from us.